Greetings and welcome to yet another video. Today we'll discuss about the conventions or codes of lines in engineering drawing. A drawing is made up of different types of lines. In mathematics and geometry, line is a one-dimensional figure. So it has the length only and no width. Engineering drawing is combination of different types of lines. There are continuous lines like this one, wavy line, dashed line, chain line, zigzag line, and so on. Whatever be the lines, their thickness may be different. For example, one continuous line may have three different thicknesses. One is thick line, another is medium, and another is thin line. And same is the case with wavy lines, dashed lines, and chain line. As per ISI 1972, there are some lines designated by the letter A, B, C, D, and up to H. A is for continuous thick line, B is for continuous thin line, C is continuous thin wavy lines, and D is short dashed medium line. And dashed line are the combination of short dashes and they are equally distributed. Again, there is a line long chain thin line. Chain lines are combination of long dash and short dashes and they are uniformly distributed over the length of the line. F is the line type, which is the long chain thick at ends and thin elsewhere. You can see from this line that at the two ends the thickness is more and at the middle portion or at the central portion the thickness is less, and that is the special characteristic of this line, and it has some special application that we will discuss later. Z is the same chain but it is long chain and it is also the thickness is more, and H is short zigzag thin line. Now let us understand the thickness of the lines. There are three types of lines so far as thickness is concerned. One is the thick line, another is medium line, that means its thickness is medium, and another is thin line. The thickness of the lines should be chosen according to the size and types of the line group used on a drawing. The standard convention is that a thick line should be 3 times the thickness of the thin line. And also, thickness of the medium line is 2 times the thickness of the thin line. And of course, the thick line is 3 times the thickness of the thin line. As I have mentioned, as per ISI 1972, there are some groups of line. This is called line group. And first one, we will discuss the line group 1.2. And that means the thickness of the lines and the line types are defined under this group. So a continuous thick line will have the thickness of 1.2 under this line group, and B type, that means continuous thin line, will have the thickness of 0.4 and so on. Short dashed medium line will have the thickness of 0.6. You can see from the relation also this 0.4 and 1.2, that means 3 times the thickness of the thin line. For medium line, the thickness of the thick line is 2 times the thickness of the medium line. E is long chain thin line. F is long chain thick at ends and thin elsewhere. That means the thickness at the ends are 1.2. At the two ends, the thickness will be 1.2. Z is long chain thick line with the thickness of 1.2 throughout the distance. H is the short zigzag thin line with the thickness of 0.4. So this constitutes the line group 1.2. This way, there is also another group, another three groups that we are going to discuss. But before that, the general rule is that the thickness of a thin line is always greater than or equal to 2 times the thickness of the thin line. It may be 3:1 also. The ratio of thickness of thick line to the thickness of thin line is always greater than or equal to 2:1. This is line group 0.8 as per ISI 1972. So here the thickness starts with 0.8 for A type line, that is continuous thick line, and other thicknesses are given here. And the only difference is that the long chain thick line has the thickness of 1.8 in this group. This is different from line group 1.2. Similarly, line group 0.5 is like this. The continuous thick line has a thickness of 0.5 and continuous thin line has the thickness of 0.2 and so on. So there are 4 line groups. One is 1.2, next 0.8, 0.5 and 0.3. And the thickness of each line A, B, C, D, E, F, G and H, these thicknesses are defined under this line group. For A type line, which is continuous thick line, the thickness will be 1.2, and for B, the thickness is 0.4 and so on as per ISI 1972. And these thicknesses will be different for other line groups. Now let us discuss about the use and applications of different lines and also their description to understand the lines properly. So there is one type of line that is called visible outline or object line, or we can say principal lines. These are the lines drawn to represent visible edges and surface boundaries of objects. Let us take one drawing of an object. So this is the object, and if you look at the object from different angles, say if we look at the object from the top, then we can draw this diagram, engineering drawing for this object. And if we look at the object from this side, say this is the front side, then the diagram will be this one. And if you look at the object from the side, which we call the side view, then the view will be like this. These lines represent the outlines, that means visible edges are shown by this engineering drawing. So in this case, we have to use visible outlines or object line or principal lines. And the general convention is that we have to use A type line for this type of outlines. And A type line, already we have discussed, this is continuous thick line. So for all these cases, because it is the outline of the object or surface boundaries of the object, so we will use continuous thick line because these are the visible outlines or object lines. There is line called dimension line and extension line. So these are the thin continuous line for giving dimensions to the object. This line terminates in arrowhead where the dimension lines meet the extension line. So we'll take one example here. These are 3 different views of the object. This is the top view, this is front view, and this is the side view. So for this, the dimensions are shown like this. Dimension is shown like this. So this is dimension line which has the arrowhead at the 2 ends, and at the 2 ends there is another line which we call the extension line. So to show a dimension of a figure, in engineering drawing, two lines will be used. One is the dimension line itself and the another is extension line from the object. In this case also, this is the dimension from this point, from this line to this line, from this to this, and this we'll call this is extension line, this is extension line, and this is dimension line. So as per convention, for dimension and extension line, we have to use B-type line, which are continuous thin lines. Now the center line or the pitch line, etc. For every object, there are some symmetry. There may be some symmetry. It may be symmetrical about some line, about the axis and so on. So to represent that type of line, about the symmetrical line or axis line, center line or pitch line are used. These are used to show the center and location of a cylindrical, conical and spherical object, because all these objects are symmetrical about an axis or about some line. Let us understand this with the help of this diagram. So in this object, there is one circular hole on the object, and that is represented by this circle. So this circle is symmetrical about this axis and also symmetrical about this axis. For these two lines, we have to use the center line or pitch circle line or whatever we call. And for such lines, from this diagram we can see this is the center line and they are chain line. So center line are represented by E type of line, and those are thin and long chain. So E type lines will be used for center line or pitch circle line, and the lines are thin and long chain lines. Now there is also another line called the construction line. It is a thin continuous line, and this construction line is used for constructing a figure, and they are shown in geometrical drawing only. For geometrical drawing, we have to use the construction line. Now another important line is hidden line. The hidden line is represented by dashed lines. Dashed line we discussed, that is the combination of short dashes. And hidden line is used, it is used to show the invisible or hidden parts of the drawing. We take the same example once again. For this object, these lines are visible lines or outlines. But if we look at the object from the front side or from the side of the object, that means for front view and for the side view, we cannot see this circular part from these two views. But there is a circle that can be represented by these two lines in front view and by these two lines in the side view. And these lines are dashed lines. So for any hidden or invisible part, we have to use the dashed line. And for dashed line, D type line is used. These are short dashes with medium thickness. Next is the cutting plane line. That these lines are used for the location of the cutting plane in a object. This is our object. If we want to cut this object at this line, then that means through this plane, if we want to cut the object, then the object will be something like this after cutting. So for this cut section, this is cut section and this is also cut section, and this section is not affected by the cutting. The line or plane on which the body is cut has to be shown in the diagram. So in this diagram, for this line, cutting line or cutting plane, this line is shown by the line CC. Say that means this is CC, that means this is CC. So this line is this type of line, and at the end the thickness is more. This is the speciality of the line for cutting plane line. And after cutting this, the cut section is shown over here, because this is written as section CC. That means due to cutting of the object at the section CC, we will see the object like this. Now for showing this cutting plane, we have to use some special line that is called F type line, which are long chain, thick at ends and thin elsewhere. That means the thickness at the end is more than the thickness at the middle part. Similarly, there is short break line. It is represented by a thin freehand, and a line is used to show the break of an object for a short length. We take this example. If we want to represent this object in a diagram, it will take more space in the drawing sheet. But we can also represent this sheet or this body like this by using this line, which is wavy line. This represents that this body is extended to a few distance from this line also, and therefore the whole drawing will take less space. This way we can represent a big sheet by using a small space, and for that the line used is wavy line. Similarly, there is long break line. Suppose we have a long object. It may be a line, it may be any body. So we have a very long object, and if we represent the object in the drawing sheet, it will also take a long distance in the drawing sheet. So instead of taking the whole length of the object, we can represent it like this. This represents that there is a break within the line, but this is actually a long line or long object. So a considerable length of the object is represented by a short line, and which is short zigzag line with less thickness, thin line. Section line or hatching line, it is used to make a section evident or prominent. Because of this section, what happened to the body, that can be represented. As we have seen, this is the section CC, and this is the cut section line. Due to cutting of the object at this section, we get a section which we call the section CC. That means after cutting, we will see the object like this. These two parts, after cutting the object, it will represented differently. And how it is represented, this section is affected by the cutting. And in a simple engineering drawing, we don't use any color. So instead of that, there is one convention. These sections are represented like this. So these are the lines called section line or hatching line. And the characteristic of the line is that it will always be at an angle of 45 degree to the outline of the section. So they are continuous thin lines, that means B type line, drawn at an angle of 45 degree to the main outline of the section. So these hatching line are at an angle of 45 degree to the outline of the main object. Another line is leader or pointer line. It is used to connect a node with the fissure. This is a dimension actually. This is the dimension, and this dimension is for the diameter of this object or diameter of this circle. Now this diameter is not shown inside, but it is shown by this line, and this line has an arrow at one end, and at the other end node or fissure is written, and it is written that phi 3.00. This phi represents the diameter. symbol of the diameter. So it represents that the diameter of the circle is 3.00. If we want to say the radius, then we can write r 1.5. That means radius of the circle is 1.5. So this way, this line, leader line or the pointer line, it consists of two things. It has an arrow at one end, and at the other end the note is written. And in this example, the note is that the diameter phi is 3.00.